To give you a little bit of background before we jump right in, for those of you who may be tuning in for the first time to our webinar series. To give you a little bit of background about Paige and Paxton, in the mid-1990s, our co-creator, Rachel, was a mother of two girls, and she really made a concerted effort to expose her daughters to a lot of different formal and informal experiences in science and math. And unfortunately, a lot of those experiences were met at the dismay of her daughters. And so what she did is she created two puzzle piece characters to make those complicated concepts less intimidating. And a lot of her motivation around that was based on her own challenges that she had in the subjects growing up. And so she really wanted to give her daughters the every advantage possible. So then we fast forward to 2011. Her daughters, one now in dentistry, the other in financial services, thought it would be really great to bring the characters back to life and apply those same concepts and methods to today's classrooms. So since that time, the mother-daughter trio and their puzzle piece characters have been on a mission to engage a new generation of new little learners in STEM, and at the same time, hopefully change the course of a nation in the process. So since 2012, the Paige and Paxton approach has been used in 15 school systems and counting. One of our biggest clients, who a lot of you guys are on the call right now, is Chicago Public Schools. We've also trained more than 500 educators in 6 states on STEM learning in the classroom. And luckily, that Paige and Paxton is also coming at a perfect time as the U.S. is trending in the opposite direction when it comes to science and engineering. For example, about 30 years ago, about 40% of the world's scientists and engineers resided in the U.S. And today that number has shrunk to about 15%. So that's why we also have designed these webinars for educators, because we know there's no other profession that has such an impact on a society. So we offer these free webinars to you so that you can have a safe place to ask those questions about STEM, get best practices, and really learn from people who are doing it on a day-to-day basis and who have specific expertise in this subject area. So, and that's why we're super excited to have Kelly Borden on board. She really, the presentation today that she's talking about and the concept around citizen science, which she'll go into a little bit later, really represents how science is not just something that, people do in a lab, but it's really something that is a contact sport. And it's really something that we all can and should participate in. So what I'm going to do is I'm going to hand over the mic to my namesake, Kelly.
Hi, everyone. Thank you so much for joining today. As Kelly mentioned, I'm the Citizen Science Education Lead at the Adler Planetarium in Chicago. The planetarium is also home to a web development group that builds a thing called Zooniverse that I'll be talking to you a little bit about today. So let's just go ahead and get started. I'm very thankful to be here, and let's see, I'm trying to, oh, there we go. Advance the screen, and so we'll get started. We'll hope that you'll follow the chat with us today on Twitter, asking questions. Any questions that don't get answered during the conversation today, I have some time allotted after this that I'm going to be spending online, so I'll be happy to engage with you folks there. So let's just go ahead and get started. All right, so before any talk I give, I always kind of like to give an overview of what to expect. Today's talk will be broadly in 3 sections. I'm going to talk to you about the birth of a project called Galaxy Zoo and something called the Zooniverse. We're going to talk about different types of citizen science, and I'm going to give you some citizen science projects that I would recommend for early learners. Hopefully at the end of this conversation, you will be able to walk away with three things, which is know what citizen science is, understand how it works, and have some ideas about how to get early learners involved in citizen science. I should tell you now, we're going to start off the conversation with astrophysics, which is a subject I do not have a background in, but it's the framework that we're going to tell the story of citizen science through. But it's actually pretty interesting and pretty approachable. Sorry, I'm just trying to advance the slide here. I'm having a little difficulty. Thank you. So in its most simple definition, citizen science is doing science together. So something that many of you probably do a lot of in your classrooms. In this case, we're joining professional scientists and non-professional scientists. Any interested member of the public who wants to contribute to current research can do so through these projects. I think the easiest lens to understand citizen science through is actually by talking about the development of a particular project. So we're going to start with talking about a project called Galaxy Zoo. Before we get started with that, let's do a little bit of astronomy background information. So a galaxy is a system of millions and billions of stars held together with gravity. There's gas, there's dust, pretty simple stuff. There's generally some confusion in the public about the difference between the solar system, a galaxy, and a universe. The way you can sort of remember the difference is that the universe holds billions of galaxies, galaxies hold billions of stars, and a solar system generally involves one star, although there can be more in a complex solar system. You might have binary stars orbiting around each other. I usually, when I give this talk, ask the audience if they happen to know what the name of our galaxy is, but since we're doing this on a webinar series, I'm going to give you a moment to pause and think. And the name of our galaxy is actually the Milky Way. So you've probably heard of that quite a bit. I do love the fact that it shares a name with this delicious candy bar. So that's some basic information for you about galaxies. This image, I think, is really impressive. This image was taken by the Hubble Space Telescope, and it's called the Hubble Deep Field image. Each of those colorful blobs is, in fact, a galaxy. So this, is that kind of point in the conversation where, you start thinking about the infinity of our universe and our very small place in it. So as I said, the universe has hundreds of billions of galaxies. Each galaxy has hundreds of billions of stars. And our own sun is just one star in one single galaxy called the Milky Way. There are approximately 100 billion galaxies in the observable universe. There's a lot more out there that we actually can't observe at this time. So let's get started in talking about the development of Galaxy Zoo as a citizen science project. So this lovely telescope is called the Sloan Digital Sky Survey. It really sort of revolutionized how we know about our own galaxy and the universe as a whole. As science is getting more complicated and we're able to build more sophisticated methods of collecting data, we get a lot more of that data. So this telescope has imaged over 50 million objects in our galaxy and universe. And that kind of presents a problem when we get to talk about analyzing that data and starting to understand things from that. So I'd like to introduce you to the hero of our story. This is Dr. Kevin Shavinsky. He is an astrophysicist. Most of the story takes place while he was a PhD student at the University of Oxford. And Kevin studies galaxies. Specifically, he studies galaxy morphology. And all that means is that we are looking at how the shapes of galaxies change. The problem? Kevin, when he was a PhD student, he needed a million galaxies classified. Basically, he needed to sort them into categories based on their shape and features. I'm sure many of you with your students do a lot of talking about categorizing and sorting, and that's something that 98% of all scientists have to do routinely as part of their job. And so Kevin gave it a try. He gave himself a month to do as many as he could. In fact, he only got to 50,000 before he sort of, threw in the towel. So one night, Dr. Shavinsky, Kevin, was out at the pub, as you do when you're a student at the University of Oxford, and he was speaking with his colleague, Chris Lintott, and they were just kind of talking about how could we possibly solve this problem? How could we, get a million images classified fairly quickly so that we can actually do the science that we want to do, so that we can discover new things about how galaxies change over time. And so the solution they came up with is something called crowdsourcing. And crowdsourcing is a very easy concept. It's just taking a really large problem, like having to classify a million galaxies, and breaking it into small pieces that many people can help with. Perhaps you've heard of the power of the crowd before. That's exactly what this is about. So now the next question is, where do you find all of the people? Clearly the answer is the internet. The internet is home to what we call cognitive surplus. And I'm sure that you recognize these little characters here. These are angry birds. And every day, the equivalent of 16 years of human brain power is spent hurling birds towards targets. So knowing this, Kevin and Chris wondered, could we take some of this time that people spend online hurling birds at things or liking things on Facebook and just apply a fraction of that towards scientific research? And that's where Galaxy Zoo was born. Galaxy Zoo is an online project where volunteers can sign on, and they are shown a picture, much like the one you see here, to your right, of an image from the Sloan Digital Sky Survey, that big telescope I showed you earlier, and they're asked to make a few observations about the galaxy at the center of the picture. There's help buttons and information, and it's pretty easy to do. Now, of course, when they first launched this, there were two big questions. A, would anyone want to help them? And would non-astronomers be able to do this? Because clearly you want to have accurate results. It doesn't do you any good to have a million images classified if they haven't been classified correctly. And so let's take a look at some of the answers to those two questions. So this is what I call my training slide. In it, you have two different galaxies. The galaxy on the left of your screen represents, there are several different kinds of galaxies, but in general, we're talking about two. One of these pictures represents what we call a spiral galaxy, and one of these galaxies represents a smooth elliptical galaxy. And I'm willing to bet my pay this week that most of you can tell the difference. I wonder if on the chat anyone can say which one they think is the spiral galaxy. Is the one on the left, the first one, or the one on the right?
We have some people saying left. Left.
Perfect.
Mm-hmm.
Great. You're absolutely right. The galaxy on the left is a spiral galaxy, and the galaxy on the right is what we call a smooth elliptical galaxy. Now, I don't think that there are any PhD astrophysicists in the audience. If there are, hello. I do not have a formal background in astronomy, and I imagine many of you don't as well, but you can tell the difference between those two objects. So the answer to the first question, or to the second question, are people good at this, is yes, they are. Let's go to the next slide. So Chris and Kevin launched this project in 2007. And you can see on this graph, if you look at along the x-axis, the bottom axis, that's time in hours when they launched the project. And then you can see the classification rate, how many images were being classified per hour along the y-axis. And as you can see, at about the 24-hour mark, we were looking at 40,000 galaxies being classified in an hour. At the 42-hour mark, oh no, I guess at about the 40-hour mark, excuse me, we reached about 50,000 classifications per hour. Now, if you remember, I said earlier that Kevin did 50,000 classifications in 1 month. So by that point, they were doing that many classifications in an hour. So you can really see how this speeds up, or has the potential to speed up, the process by which we analyze this data. So one of the biggest questions that we encounter with citizen science are people are worried that they're going to break science if they happen to get an answer wrong. And the thing that I want to emphasize is that is absolutely not true. We do have fail-safes so to ensure that if you get an answer wrong, if you misclassify a galaxy, it's no big deal. I just wanted to show you this image right here. This is from a classroom tool called the Galaxy Zoo Navigator. And one of the major checks that we do to ensure the accuracy of classification is simply consensus. So on the screen, you can see a couple of images that have been classified. And you can see by the bar chart on the side, you can see how people classified it. Now, in all cases, there's an overwhelming answer that the majority of people seem to agree upon. And in fact, what we found is that in about 99% of cases, the majority answer is in fact the correct answer. Now, sometimes you will have a classification where it's more split. So what we would do in that case, we would just have more volunteers classify it. In Galaxy Zoo, each individual image is classified by between 40 and 50 different people. So that ensures good results, accurate results, results that we can do science with. So now Galaxy Zoo is about 7 years old now. Oh, excuse me, 8 years old. It's just about to turn 8. And over that time, we've had over 350,000 volunteers classify over 150 million images, approximately 60 academic papers, peer-reviewed academic papers have been written using the data that our volunteers have provided. And what's even better is that something called serendipitous discoveries, things that we didn't expect to happen, but did. So these are the green peas, and you can see some sort of blobby images in the background, these green round things. And what happened was volunteers on Galaxy Zoo, there's a talk forum where you can discuss images and interface with a scientist. Volunteers began noticing these green blobby things, and they wanted to know what they were, so they asked the scientists, and the scientists dismissed, saying, oh, they're nothing, it's don't worry about it. But our community kept on pressing, saying, no, what is this? And so the scientists, because the community so very much wanted to know what these were and know more about them, started doing further research on them. And it turns out this is an entirely new type of galaxy that had previously been undiscovered, that if not for the Galaxy Zoo volunteers, we may not know about now. So by having eyes on the data, having people looking at it, you find things that weren't expected. And that's kind of the most exciting part of science, I think, is when you have an unexpected result or find something new. Another instance of a serendipitous discovery by our volunteers on Galaxy Zoo, is something called Hani's Vorwerk. In this image, you can see there's some beautiful spiral galaxies, but you might notice directly across from where it says Hani's Vorwerk, there's kind of this green blobby thing. In a lot of ways, I think it looks like Kermit the Frog with his arms outstretched. And that, in fact, is an entirely new type of astronomical object that was discovered by a Dutch school teacher named Hani van Arkel. She was on Galaxy Zoo classifying, saw a weird blobby thing, wasn't a green pea in this case, but posted it on the forum and actually saying basically, like, what is this thing? And it is actually discovered an entirely new type of astronomical object, which I won't go into what it is right now just because it takes a long time to explain. But the object was named after her. Vorwerk happens to be the very technical astronomical term. It actually is just the the word in Dutch for thingy. So, you know, this type of object is now basically just referred to as a thingy. So multiple other voorwerps have been discovered since this. Hanny's efforts have directly contributed to really advancing the field of astronomy. So that's Galaxy Zoo. Now, Galaxy Zoo is, it worked really well. Crowdsourcing and online citizen science worked terrifically. And so Chris Lintott thought, well, you know, this is working great. Let's do it with more projects and more branches of science. And that's how the Zooniverse was born. Zooniverse is real science online. Currently consists of about 31-ish different projects. That number is about to increase dramatically over the next year. So now I thought I'd talk to you a little bit, now that we've talked a little bit about how citizen science works, it's all about crowdsourcing, I thought it'd be good to talk about the fact that there are different types of citizen science projects. Broadly speaking, you can divide citizen science projects into either data analysis or into data collection. Now, the basic difference between the two is data analysis projects, like Galaxy Zoo, the one I just told you about, is where volunteers make observations of data that's already been collected by scientists. So with Galaxy Zoo, that's data from the Sloan Digital Sky Survey or other telescopes sort of teamed on making observations of objects in our universe. There's another type of citizen science project called data collection projects. And this is a little bit more of what most people think of when they think of citizen science. Data collection projects are where volunteers, instead of working with an existing set of data, they actually help scientists create a set of data. So volunteers are making observations and collecting data for scientists. One great project that I highly recommend that you check out is called the Monarch Larva Monitoring Project out of the University of Minnesota. And that asks people across the country, or well, across North America as a whole, in fact, to monitor milkweed plants that grow around their house, as that's the food source for monarchs and where larvae are, where eggs are often planted, and to make observations on the development of those larvae and report that information via the web back to the project. So in this way we can get a big data set about monarch larvae and try to better understand what types of environments they thrive in, where there are risks for them. Excuse me. So let's talk a little bit about using citizen science with early learners. So citizen science is really about three things. You're making observations, whether you're making observations of galaxies on Galaxy Zoo, or whether you're out in the field collecting information about monarch butterflies. You have to rely on those skills. And that's something so critical to get our early learners to do. And it's something that they do naturally. It seems to me that the younger the child, the more natural a scientist they are. And somewhere along the line, some kids use that. So it's really important. And that's why I think many of you are here, to really foster those skills and keep them as lifelong skills. Citizen science is all about asking questions. It's all about, interpreting what you're seeing, whether it's what you're seeing in a galaxy or what you're seeing, what kind of behavior you're seeing if you're observing birds. And it's all about working together. It's all about that idea of crowdsourcing. And so when I say using citizen science projects with early learners, I don't mean setting up stations in your classroom with a citizen science project on the screen and having students just go and classify. It's really about the conversation of together. I'm about to talk about 4 projects that I think are good fits for early learners. And this is a great thing that you can do as a class together. Or to encourage your students to do with their families. It's a great activity, and it really is a great way to foster that natural curiosity and to help students feel like they're really contributing to science, because they are. A lot of citizen science projects, or a lot of projects that call themselves citizen science projects, may or may not be. They may or may not be actually using that data for research. All the ones I'm going to talk about today and all of the ones that you'll find on zooniverse.org are. All of that data is being used by scientists, and they are hungry for it. So let's talk a little bit about a couple of suggested projects other than Galaxies, which may not be the most appropriate for young people, but you know, I've actually been able to do it with 5-, 6-year-old students before, where we were just working together, and it makes for some great conversation. So first, I'm going to talk to you about 2 other Zooniverse projects that are data analysis projects that are part of the Zooniverse platform. They are accessible online, and we invite everyone to participate. So the first one I wanted to talk to you about is a project called Snapshot Serengeti. This project was one of the first projects that we launched that was not an astronomy project. In this project, we're asking people to count and identify animals living in Serengeti National Park. Scientists need this information in order to understand how all these different populations within Serengeti National Park in Tanzania interact, and to better understand predator-prey dynamics, so food web types of things. And so you simply go online, there's an image from the interface, and you are presented with a picture, and you have a list of the different animals that could be to your right, and there's different ways you can filter it. You know, you can filter it by pattern, or by build, or if you just know what the animal is, you can just click on it, and then you're asked how many there are and what they're doing. So this project is great to do with young people, although they might not be able to do it on their own if they're not reading at a level high enough, which, let's face it, probably most students aren't going to, you know, most pre-Kers aren't going to be able to read Heart of East. But it's amazing how quickly they learn the difference between the different animals. So they can identify it, they just might need some help with actually entering it. There is a field guide that you can look at to compare pictures that you're seeing and being asked to classify to what the different animals look like. So it's actually very user-friendly. After about 3 classifications, young people are aces at it and are gangbusters. It's really exciting to watch that. Another nice thing about this project is that you get to look at images like this. This is an actual image that was taken on Snapshot Serengeti. The way the data is collected in this project is that there are camera traps set up around Serengeti National Park with motion sensors on them, and when something walks by, pictures are triggered. Another suggested project that I would have is called Chicago Wildlife Watch. It's very similar to Snapshot Serengeti. It has the same basic interface, but instead of pictures from around Serengeti National Park, these are pictures from around the Chicagoland area, also caught with camera traps. This data is needed by ecologists at the Lincoln Park Zoo to better understand the urban environment on our wildlife. There's lots of data, they need lots of help, so I highly encourage you to go ahead and sign on and check this one out, especially with your students. It has that nice local connection if you are based here in Chicago. I do just want to point out, I absolutely love the black and white image down on the lower right-hand corner. That's obviously a nighttime image, but the interesting story is there are 4 raccoons, excuse me, in that image, but one of them is an albino, and this seems to be his family. And so you never know what you're going to see. It's very interesting. You do see some dogs in these pictures, and the occasional human, but it's actually quite a good project. So I have 2 other projects to suggest to you. These are both field-based projects, so these are both data collection projects where you're out trying to help scientists by creating their data set. The Cornell Lab of Ornithology, I cannot say enough good things about them. They are, in my opinion, one of the organizations doing the absolute best data collection citizen science projects. They have several of them, as well as educational resources to accompany it. The specific project I was going to mention is called Project Feeder Watch. Now, this is a winter project, but it's a really great one to do with young people, either in the classroom or as a family. Basically, you put a bird feeder in your backyard and you make observations and report that information back to the Cornell Lab of Ornithology. It's absolutely wonderful. They also have several other projects on their website and several other tools. They have a great new tool that's name is escaping me at the moment right now, but it is a great tool for actually identifying types of birds. It's an app. It's fantastic. The other project I wanted to recommend is called Project Budburst. And just like the Project Feeder Watch, this is about making observations of the natural environment. In this case, it's about recording observations about plants in your community. So, and the nice thing about this project is you can either make an observation one time, or you can do it throughout the season. You can look at several you can look at the same plants throughout the season to record, the different flowering stages, and then sharing that information back. And so there's a network of Project Budburst volunteers across the country. So those are the 4 projects that I was going to discuss. I can go on and on about more, but I certainly want to get to your questions. A few resources that I would recommend. SciStarter is basically the place on the web where all the citizen science projects are listed. It's just an extensive searchable list of projects. You can look by subject, you can look by age level, you can look by duration of time you want to spend. It's really fantastic. Zooniverse, that's the platform that I work with. We have 30+ online projects, citizen science and digital humanities at zooniverse.org. Of course, I'd love for you to go there and check out some of those projects. And then also the Cornell Lab of Ornithology, as I had mentioned previously. So that's about it for me gabbing at you. I would love to know if you have any questions or things you'd like further information about.
Yeah, so if anybody has any questions, just you can either tweet at us at Paige and Paxton on Twitter, or you can just go ahead and write your questions in the box right here. So I have a question, Kelly. So what are some discoveries that you guys have had from children within citizen science?
That's a really great question, and unfortunately, one I can't actually give an answer to. At least in terms of the Zooniverse projects, we try to make the barrier to entry really low, so we don't collect demographic information from our volunteers. You just need an email address to sign up, and so I can't actually answer that question, but it's a great one.
All right, so we have a question from Rochelle. She says, I am a diverse learner teacher for primary age students. How much differentiation is needed for these programs?
I think that's a great question. I think it largely depends on the program that you're doing. If you were, for example, going to do Chicago Wildlife Watch in your classroom, I think that it would be worthwhile to, sort of do some sort of pre-activities about, what are the different animals that we observe in our community, and, maybe going out and practice making those observations, or even taking pictures, so that all your learners will understand where that data kind of comes from. And then I would sort of facilitate it as a whole group thing about, okay, we've made some observations outside around our school or in our backyard. Now let's bring it in and let's make some observations using the data that these scientists have made. So you can, if you have the ability to project from a laptop, or from a computer, you can kind of bring it up and just project it, and then just ask the students what kinds of things they're seeing. And I think that's an easy way to help with confidence, especially. You're not putting yourself out there as much. So that's one way I would suggest.
We have a question. How can we extend this knowledge to our students' parents? Can they access this info as well? And what about at home?
Oh, absolutely. So all of the Zooniverse projects are only web-based. So those can be reached through any device that can get online. And so it's accessible by pretty much, hopefully, most of your families. Some of the other projects, the more field-based projects, I think a nice way to kick off those projects, if that's something that you're going to do in your classroom, would actually invite families in to do it. Make it a family day of learning, of going out, and with Project Budburst, for example, you could do that as a special event for your school community. Siblings could come, and all of the information that you would need is on the Project Budburst website, but you could kind of make it a day of like, we want to see what kinds of plants are on our school grounds, and you could do that information, compile it, and then share it back with the project. So it's citizen science can be a nice social thing. And all of these projects all have websites that parents could also share.
Awesome. Another question from Melinda. If I were to launch a beginning project, she says she preaches TK Young Fives, or I guess that's pre-K Young Fives, which would be best? I did do the bird feeder watch 18 years ago with my kindergarten kids, and it was fantastic.
I think it might depend on what your kids are interested in. I sort of am realizing now every project that I talked about, other than Project Budburst, were animal-based projects. So I think that those are, I think that's, at least in my experience working with young people using citizen science projects, that seems to be a nice point of entry. So I think you could do, Melinda, if you happen to be based in Chicago, I think Chicago Wildlife Watch would be fantastic, because it has a nice local connection, and there are animals in there that they already know. And I think they'll also be surprised at how many animals live in Chicago that they might not have thought of or realized. I mean, we have coyotes living in the city here. So I would suggest an animal-based project. Another good starting point is SciStarter.com, that website I mentioned earlier, that sort of has a listing of all. We barely scratched the surface with the projects that are available.
We have, and Melinda said she is in California. Is there anything out of, the Berkeley, California area?
Oh, yes. You should check out the California Academy of Sciences. Does fabulous, fabulous work with citizen science. They have an excellent app called iNaturalist, which you can use to take pictures and identify different plants and animals. I mean, that app is used all over the world, and so you can help build a collection of data. I believe that and I'm not 100% sure I'm getting the name of the museum right, but the LA Natural History Museum also has some citizen science programs out of their museum that might be worth checking out, and that are specific to California. In terms of the Zooniverse projects, the two that I can think of, and I don't know how well these would work with early learners. I'm sure that they could be adapted, but that's something I can't think of off the top of my head. But we do have a project called Plankton Portal, which is all about measuring and identifying zooplankton. And one of the data sets that you can choose to work on in that project is from specific area I can't recall the name of, but it's off the coast of California.
Awesome. Thank you so much. Are there any other questions from the audience? Okay. So if you guys have any other questions, of course, feel free to contact our guest speaker via email. Her email address is listed right there, kborden@adlerplanetarium.org. If you would like professional development credit for this webinar, feel free to email us at webinars@paigeandpaxton.com to receive professional development credit hours. And then also the webinar transcript and recording will be available about a week after our broadcast. And also feel free to ask questions of us and our guest speaker via Twitter or via email. So either way, we'll get those answers to you.
Absolutely. Thank you so much for having me, Kelly.
Yes, thank you. And just so you guys know, we'll be taking a break. We're on summer break just like you guys. So we'll be back in September with a whole nother slew of professional development opportunities for you guys. So thanks again for tuning in to Summertime STEM Activities for Little Learners.